Hello everyone, welcome back to my YouTube channel. In this particular video, we'll be looking into another type of prompting technique which is really very special, and the name of it is ReAct. Yes, it is a combination of two words, reasoning and action. First, we'll be looking into the definition of it, through which you will be clear with the ideology of it. So let's have a look at it. So by the definition, ReAct is a prompting framework that combines reasoning. You can see the first part, RE, comes from the word reasoning, and acting, that is nothing but the next part, that is act. So it's a combination of two things, reasoning and acting, in an iterative process. So this process goes on continuously. But obviously, there has to be some breakpoint for it. The ReAct prompting framework enables the large language models to solve the complex problems, or I would say the task, by breaking them down into a series of thoughts, steps, and actions, with each action followed by an observation that informs the next step. First, it thinks about some steps, then it takes action according to those steps, and then it looks for the observation whether that action has met the expected result or not, and it will iteratively do this process until it reaches the final output. So this is what ReAct framework is, or I would say the ReAct prompting technique is. I hope you must have got an idea of what exactly ReAct is. Now we'll be looking into the working of it. Now, through the ReAct prompting technique, the model follows a structured thought process. So, the thought process will be fixed. It will be something like, first, it will contain thought. The model will first have a thought, analyzes the current situation. So, whenever a query is fired along with the ReAct prompt, so first, the LLM, according to the ReAct prompt, what it will do, it will analyze the current situation. What exactly is the thought as per the query? Once it understands the thought, then what it will do? It will take the action. Now, for taking the action, it will check for the available tools or allowed actions that it can take. So, it might contain list of tools which it might choose from to take action, or it might first check what all capabilities it has. So according to that, it will decide to take what action according to the thought. Next, what it will do, it will observe according to the action what output it has got. It will observe it. So this phase is nothing but observation, where the model processes the result of the action. It will check whether according to the query the observation has met the expectation or not. If not, then what it will do, it will iterate over these three steps again and again until it reaches the expectation. So the fourth point will be repeat until reaching a final answer. Now, obviously, the final answer, whatever it generates, it will be generated based on the capabilities or actions that are provided, or I would say that the LLM can have an excess of. So this is a basic workflow of ReAct prompting. First, it will think, then it will act, then it will observe, and then it will repeat it until it reaches the expected output. Now we'll see the template that it follows. See, the ReAct framework, or I would say the ReAct prompting framework, follows this template. First, it will take the user query. It will be any user query which might contain series of queries or one single query. And as per the ReAct workflow, first it will give a thought. So the thought will be like this. Let me approach this step by step. So according to the query, it will just create a thought how it could reach the final output. Next, the phase of action comes. So inside the action, I already told you that there are certain tools from which it has to pick one. So here we'll be providing the list of tools, or I would say the list of capabilities that the LLM can perform or access. So here it will contain the tool name, description, tool input, and so on. So based on this, it will understand the action that it can take. And thirdly, it will observe as per the action taken. So under the observation comes the result after using one particular tool. Now let's say over here, according to the user query, the observation doesn't meet the expectation. The observation or the final answer is not up to the mark. Then the React framework is that smart that it will iterate over it again to correct the output. So again, the thought process comes. So based on this observation from the previous process, I would say, so what it will do, it will just give another thought based on the observation that it got from the previous process I should do. Then it will again think of different actions, different capabilities that it has. You can see over here, again it will choose from one tool, again it will choose one tool and will try to process. Now again it has got an observation over here, that is nothing but the result from using the tool from the listed tools. So now over here, it will get some information from the tool that it has used. Now again, it will check whether the observation that it has got is enough to answer the user query. It will check that. And for that, it will obviously have to give a thought. So the thought would be like this. Now I have enough information to answer. You can see it has reached to this particular output by simply looking at the observation from the previous processes. It has got the observations from using the tool that it has picked up, and it has checked whether the information that it has got from the tools is capable enough of answering the user query. If it feels that yes, it is capable of answering the user query, then it will give a thought like this: now I have enough information to answer. Then it will simply reach the final answer. It will be the complete answer to the user's question. Obviously, this answer that it has created will be based on the outputs that it has got from the usage of tools that it has used before. So I hope the approach is clear to you all. The template might have cleared all your doubt regarding the React workflow. It will keep iterating over the thought and action until it feels that the observation information is enough of answering the user query. So I hope this template is clear to you all. Now that we are done with the enough theory regarding React, now we'll jump to the implementation of React prompting. So let's go. Okay, so you can see I'm inside VS Code. Now I'll be implementing the React prompting framework with the help of the inbuilt functionality that is provided by LangChain. See, in the backend, at the end, there is a prompt. That prompt is designed in such a way that meets the requirements by the React prompting technique. We can simply use the LangChain framework module for using the React prompting technique. We can simply provide the tools as well as the user query, and it will automatically understand where it has to go, which tool has to be accessed, and which action has to be taken. So the manual work reduces over here. So we'll be implementing the React prompting framework with the help of the inbuilt module present inside the LangChain. So this is what is the agenda of this particular code that we are going to write. So now, first you need to understand that inside LangChain there is a agents kind of library, and inside which we have modules. We have agent type, initialize agent. So what exactly this agent do? It will simply act as an entry point, which will take the LLM that we are going to use. It will take the list of tools, and it will obviously take the query. At the back end of the agent, the prompt will handle the scenario of choosing which tool to use for what kind of scenarios. So let's see how we can do it. So from LangChain dot agents, we'll simply import initialize agent module. Along with that, we'll also import agent type. So this will help us to specify what kind of agent we want. We have a list of agent types. So these two models we are going to import, and then what it requires is it requires tools. So it will be provided in the form of a list. So obviously there will be multiple tools which we are going to provide to the LLM, through which it will choose one for taking subsequent actions. Now, once we are done with tools, next we will be initializing the agent. So we'll be defining a variable inside which we'll be calling the module initialize agent, and you can see what all things it takes. It takes tools, the LLM, also takes the agent type that we want to use. So let's define it one by one. So the tools will be the list of tools that we are going to provide over here. So I'll just provide the variable over here. Next, it will require an LLM. So we'll be providing LLM in the variable LLM. Obviously, for now, we don't have any variable LLM, but we'll be surely defining it. Next, what it requires the agent type. So I'll define agent type, which is nothing but agent type that we have already imported over here. Dot. Now over here you can clearly see we have these many types of agent. We have chat conversational react description, chat zero shot react description, and so on. We are going to simply use this react underscore doc store agent, which is a pure form of react agent. So we'll be using this. And next we'll also define a parameter verbose equals to true, because we want to see what all actions at the backend the agent takes to reach the output. So now that we are done with this particular code, what all things we require over here? We require tools, we require LLM. We'll now define LLM first. So now over here you can see it requires the object, or I would say the variable object of the LLM that we are going to use. Now if we are using the Hugging Face large language model and you are using it with the help of API inferencing, then in that case you have the URL. You don't have the object of the LLM. So we'll have to first convert it into an object, or I would say a Hugging Face endpoint, so that we can use it in a variable and pass in to this particular module. So for that, I'll be using the Hugging Face endpoint library. So let me write simple code for it. From LangChain LLMs, I'll simply import the Hugging Face endpoint. Here you need to pass the repo ID. Now repo ID is what? It is nothing but the name of the LLM, or I would say the path to the LLM. So we'll define a variable named repo ID. Inside this you just have to pass in the path of the LLM. So here is the path. I'm using Llama 3 8 billion instruct model over here. Next thing, we'll define a variable LLM with the help of the Hugging Face endpoint that we have imported already. Now inside this, what you have to pass on. Now why we are doing this, I hope it is clear. We just have to convert this URL, or I would say the API inferencing kind of technique, into an LLM object so that we can pass it on inside this initialize agent function. Now inside this Hugging Face endpoint, we have to pass in the repo ID, which we already have defined inside the variable repo underscore ID. Next, we can have some additional parameters like max length that the LLM can output. Let's put it as 1000. Next, we can also define the temperature over here. So let me do that. Temperature equals to 0.2. Next, we'll have to pass on the API key over here. So we have a parameter called as Hugging Face hub underscore API underscore token. And inside this, we just have to pass on the API token of Hugging Face that is free to generate. If you are not aware yet how to generate a free access token, or I would say how to access an LLM from Hugging Face, then you can surely look at the video that I have inside the Generative AI playlist on my channel. Just have a look at it. And inside this, we'll simply paste the Hugging Face API key. So here is the API token. I'll simply execute this. Okay, so over here you can clearly see that the login has got successfully done. Now we'll try to access the LLM using this particular variable. Let's do that. Whether it works or not, let's see. So I'll do what? I'll simply invoke the query for getting the response. So LLM dot invoke. Inside this, we'll simply pass on a query. Let's say hi. If we get an output, we will understand that yes, our LLM is getting accessed. Cool. We are getting some output over here. We required some output and we got it. So that means till here, everything is correctly implemented. Now we are done with the LLM parameter over here. Now next thing that we have to define is the tools. We'll have to initialize the list of tools that we are going to pass into this initialize agent function. So now let's do that. So since we are implementing the tools from scratch, we'll be using LangChain dot tools. We'll simply import the base tool because we are doing it from scratch. Now for defining tools, you have different approach. You can define it with the help of a function or you can define it with the help of class. Here I'm going to define it based on the class approach. Now what I'll do is I'll define two tools over here. First is the calculator tool and second is the solar system tool. Whenever a user shoots a query, if that query contains any expression or any equation to solve, then the agent will automatically redirect this particular query into the calculator tool so that it will evaluate the answer and that evaluated answer will be returned to the LLM and the LLM will finally generate the answer from it. Next, we'll be having the solar system tool. Whenever the user asks any query regarding the solar system information that we are going to define inside our tool, then the agent will redirect the query to the solar system tool automatically and the solar system tool will return some information based on the information that we are going to define inside that particular tool related to the query that is fired. And as soon as the output is returned from this particular solar system tool, that will be sent to the LLM. Then LLM will make an observation and think whether that is correct or not, or whether that is up to the mark as per the query or not. So this is the workflow that we are going to define now. So I hope the agenda is clear. Let's define the calculator tool first. So class calculator, we are going to extend the base tool that we have already imported from LangChain. Next, here we have to define two things. First, we have to write the name of the tool that we are going to use. So it is of the type string. The name is of the type string. That is why I have written str over here. The name of our tool will be calculator only. You can define any name, but make sure the name has to be meaningful because the name and the description that we are going to provide over here will be read by the LLM, and based on that only it will redirect the query to the tool whether it is relevant or not to redirect. So make sure the name and the description that we are going to provide, it has to be meaningful and related to the tool. Next we'll be providing the description. So again the description is of the type string. We'll write use this tool when query asks for any calculation of expressions. So I have simply defined this particular statement over here, use this tool. So I'm doing this to help the LLM. Whenever the LLM reads this, it will understand that it has to use this tool whenever the query is related to any calculation of expressions. So I hope this thing is clear. What exactly is the significance of defining description over here? Next, we'll be defining a function named underscore run. Now this will be automatically executed whenever this particular tool is chosen to execute. So inside this we'll be passing on the query. First, the self parameter is mandatory. Next we'll be passing on the query, which is of the type string. Next what we'll do is we'll simply return the eval function inside which we'll pass on the query. Now if you are not aware what exactly is the usage of this eval function, let me tell you. So let's say our query is, our query is inside the variable a and we write 5 plus 4 minus 9. So this is our query, and if we pass it on to our eval function, it will simply evaluate it and will give the final answer. So you can see over here it has given the answer. So this eval function automatically converts the string into proper expression protocols and it will execute it, which will provide the answer. So I hope the usage of this eval function is clear. We are going to simply return the evaluated answer for this particular query whenever the query is related to any expression or if it asks for the answer of the expression. Now this is how we define a tool. This calculator tool is now completed. Similarly, we'll be defining one more tool. What is the name of that tool? If you remember, it is solar system tool. So we'll define a class named solar underscore system. Again, we are extending it to base tool. Now, inside this, we'll be defining the name of this particular tool. It is of the type string. We'll define the name as solar underscore system. And then we'll be defining the description of it. It is again of the type string. The description is something like this. Use this tool when the user query asks about the solar system. That's it. So whenever the LLM will have a look at the list of tools, it will look at the name and the description. Whenever the query is about solar system information, then it will simply move into this particular tool without thinking at all. Now inside this we'll again define the run function over here, which will automatically get executed whenever this class is called. Now again inside this function we'll be defining the query, we'll be passing on the query. Now for the body of this particular function we'll have some other strategy over here. What we'll do is we'll simply define our own information in this. We'll create a dictionary over here, and inside this we'll write, and inside this we'll have key and values. The key will be the words like sun, Mercury, Venus, Earth, Mars, and so on. It will be just the key term. Whenever the user query contains any of the word from that particular dictionary, it will simply fetch the value of it. So let me show you how it. So you can see what I have done over here. I have simply defined a solar system info named dictionary. Inside this I have defined some keys: sun, Mercury, Venus, Earth, Mars, and so on. Whenever the user query contains any of the words sun, Mercury, Venus, and so on, it will simply fetch the information over here, the corresponding information, and that particular information will be returned from this particular tool. So I hope it is clear. Here we are restricting the LLM. Whenever it encounters, or I would say whenever it goes inside this particular tool, it will only fetch the information that is present in this particular tool, or I would say it is going to only use this information. It will not use any outside information, or it will not use any information on which it has got trained. So this is the benefit of defining tools in React framework. For any real world use cases, like for example, if you are going to create a chatbot or any project related to information of your company, then you can simply define the information source in this particular tool. Now it can be a document source, or it can be a vector source, or it can be a web source, but whatever you will be defining, from that only the information will be retrieved. So I hope the significance of tools is clear to you all. So over here we have defined this information. Now what I'll do is I have simply defined this particular logic over here. Now whenever the query enters into this particular tool, what we'll do, we'll first lower it, and then we'll iterate over each item present inside this particular dictionary. We will check whether any of the key in this particular dictionary is present inside the query. Let's say our query is tell me about sun. Now over here you can see this particular query contains a word sun, which is exactly a word present inside our dictionary. So now what we'll do is, once it encounters any word, it will simply return that particular information. That means this subsequent information, the value of this particular key, that the sun is a star at the center of our solar system and so on. This particular information will be returned from this particular tool. And using this information only, the LLM will put the final answer. Similarly, if the query is like this, tell me about sun and Venus, then in that case, since there are two words over here which are matching inside this particular dictionary, so the information about sun will be retrieved once. Next time whenever this particular tool is called, the information about Venus will be retrieved. And since now the LLM has both the information of Sun as well as the Venus, it will simply jot them, or I would say join them, and collectively will provide the answer. So this is how the tool works. I hope this particular tool definition is clear to you all. And also note one thing, that if there are no words which are matching with this particular information that we have already defined over here, then it will simply return the general value, that our solar system consists of the sun, 8 planets, and so on. So this is how it will work. So I hope the definition of the calculator tool as well as the solar system tool is clear to you all. Now what I'll do is I'll simply execute this. Cool. Now we'll be defining object of these tools. Since we have created class, we'll be using these tools. For that we'll be defining the objects of this. So what I'll do is I'll simply write calculator underscore tool. We'll be defining object of it. Similarly, I'll write over here solar underscore system underscore tool, and we'll be calling this particular class. Now what I'll do, I'll execute this. Cool, we have now created our tools. Now that we are done with defining our tools, we'll simply pass the name of these tools in this particular list. So I'll write calculator tool, comma, the solar system tool, like this. So you can have n number of tools. You can have as many tools as you can. And at the runtime, along with the query, the list of tools will also be given to the LLM. The LLM will read the metadata over here, the name of the tool, the description of the tool, and will use it as required. So now that we are ready, we'll execute this. Cool. Our agent has got initialized. Now what we'll do, we'll simply run this particular agent by passing a query. So we'll write agent.run, and we'll simply write a query 2 plus 7 multiplied by 8. So let's execute this. Cool. You can see how it is working. See, first it has entered the executor chain, the agent executor chain. Then you can see the thought, it dynamically generates the thought. First, the thought is like this: I need to calculate this expression. It automatically understands what it has to do. Then it searches for the available tools over here. You can see the available tools are calculator tool and the solar system tool. Obviously, the calculator tool is the only tool that is related to the query over here. So what it will do, it will simply act. It will simply take the action by choosing the calculator tool. Now inside the calculator tool, you can see what we have defined. It has been defined that it has to eval the answer and return the query. So over here you can see the action input is 7 multiplied by 8. Now why it has taken this 7 multiplied by 8? Because according to the BODMAS rule, the multiplication has to be done first. So it has taken 7 and 8 at first, and it has calculated it over here. So it has got 56 as the answer. Now what it will do is, it will check whether this 56 observation is up to the mark according to this particular expression, whether it is exactly correct or not. According to this observation, it will again create a thought that it has now to add 2 to the result. So now for adding 2 to the result, it has two tools available: calculator tool and the solar system tool. So what it will do, obviously it will move to the calculator tool and it will add 2 to this particular 56 observation that it has got earlier. So now the action input is 56 plus 2. The observation that it has got from the calculator tool by adding 56 and 2 is nothing but 58. Now that it has got this particular observation, it will now have a thought that yes, I now know the final answer. And then it will simply pass on the final answer as an output, that the final answer is 58. Now we'll try to fire one more query. Let's say I write, tell me about Neptune and Venus. So now in this case, obviously the query is not related to the calculator tool, so it should not go inside the calculator tool. Instead, it should go inside the solar system tool. So let's execute this. Cool. It has got into the solar system tool. See, it has first made a thought I need to know more about Neptune and Venus because it doesn't have any information about it. So what it will do is it will check the available tools. The most relevant tool it understands or encounters is solar system tool. So the action input is now Neptune and Venus because these two are the key terms over here. So observation that it has got is Venus is the second planet. That means you can see the information corresponding to Venus key over here. It has taken that. Now again, using this observation, it will create a thought. It has now got the information about Venus, but the query asks for Neptune also. So it will make a thought that I also need to know more about Neptune. So what it will do is it will again take an action from the list of tools. It will choose for the solar system tool. The input over here now is Neptune. So now the observation from this particular dictionary will be the Neptune corresponding information that Neptune is the eighth and the farthest known planet and so on. So this is the observation that it has created. Before making a thought, it will check for all the observations that it has got and it will check whether it is meeting the requirements as per the query or not. So yes, this time it understands that yes, now it has ample amount of information to answer the particular query. So it will give a thought that I now know the final answer, and then it will simply generate the final answer. So now the final answer is Venus is the second planet from the solar system and so on. Isn't it amazing? Now, it's not up to this only. We can define an entire agentic framework, like whether the query has to go to the RAG, whether it has to go to the web, or whether it has to go for any document searching, or it simply has to execute the custom tools. So, this is how amazing is the ReAct prompting. I hope you have understood how this works and what exactly is the wonder of it. With this, we come to the end of the video. I hope you don't have any doubt. And obviously, if you have, then you can straight away put it in the comment section. I'll be happy to solve your doubts. If you like this particular video, please give a big thumbs up to this particular video and don't forget to leave a comment. Please do like, share, and subscribe to my channel. Also, hit the bell icon and don't forget to follow me on Instagram. Please join me on Telegram. Thanks for watching. Have a good day ahead.